So with that, it is my honor to introduce a HashiCorp co-founder, Mitchell Hashimoto, for this morning's opening keynote.
Hello, and welcome to HashiDays London. It's really exciting to see so many people here. London is actually one of our biggest, actually the biggest community that we have by sign-up numbers, at least that we could see. The London HashiCorp user group actually has 1,300 members. At $12.99 last night, so I'm really glad somebody joined to make that an even 1,300. Actually has 1,300 members compared to our next highest, which is San Francisco, which has around, I think, 850 or 900. So thanks to London. You're all really great. And it's quite funny because our HashiCorp user group meetups are actually larger than the first conference that we ever held. So thank you so much. And so at HashiCorp, we aim to provision, secure, connect, and run any infrastructure for any application. That is our driving vision, that's our driving goal. And by breaking it down into these different categories, we aim to make it easier to adopt our tools by separating what we're trying to solve and what we're not, so that you could adopt potentially tools to solve these things that aren't ours and still fit ours in nicely. And that's on any infrastructure, cloud, non-cloud, and for any application for pretty much any language. To achieve that mission, we have a number of tools that try to solve a certain problem very well. I know that many people in this room are familiar with multiple of them. I'm sure at least all of you are experts on one. But I just want to go through each of the 6 and just give a sentence about what it is, and then we'll actually dive into a few of these, or most of these, as part of this keynote here. So starting from the left here, Vagrant is our development environment tool. It's our first tool that we ever built. It gives you the same easy workflow to build development environments on any major desktop platform for pretty much any guest operating system as well. Packer builds images for cloud platforms, VMs, containers, and just applications, what we call sort of a deployable image. And you can do this all from a single source configuration. So whether you're on Amazon or Google or Azure, or you're building ISOs, you could just learn one format and the same commands and same workflow and build images for all those things. Terraform lets you write, plan, create, maintain infrastructure using infrastructure as code. It works with every major cloud platform out there, as well as non-cloud platforms, so things like GitHub and Datadog and Fastly and other things, and it lets you describe all of that with code rather than logging in, clicking buttons, or writing API clients yourself. Vault is our secret storage, encryption, and certificate solution service. It centralizes all your secrets in a single place and gives you clear visibility into security, threat, and so on of how to access this secret information. Nomad is our distributed data center aware cluster manager. It could run Docker containers, VMs, raw binaries, and so on. It could do so across multiple data centers that potentially live in different infrastructure providers, and it does it very, very easily. And then Consul is our service discovery and configuration tool. It's distributed, it's multi-data center aware, and again, it could run across multiple cloud platforms. It makes it very easy to find and configure your services. And so these 6 tools make up the suite of open source products that we have. Like I said, I'm sure you're familiar with all of them. And actually, up till May this year, I only have the numbers till May, we've released more releases of these than we ever have before. So we are, as a company, moving faster with every single one of our tools than we ever had before. So whether you only look at Consul, only look at something like Packer, or you're using multiple tools, you've gotten more features, more improvements, more bug fixes than we ever have in sort of the 7 years of our technical lifetime. Okay, and then we've also this year spent a lot of time building out our enterprise tooling in a number of categories. And today we have compelling features for Terraform, Vault, and Consul Enterprise. And I'm going to talk about some of those today. And we have a lot of customers here as well. So if you have questions about those, ask HashiCorp people, but ask around you as well. So with that, what I'm going to do today is actually, with all this velocity that we've had with our open source tools and our enterprise tools, I'm going to go through most of these and just highlight some of the major things that we've done. Because like I said, even if you use many of the tools, we don't expect you to keep super on the pulse about every single changelog or every single major thing. And a lot of times when I go over these, I hear from people afterwards that they've been using the latest version of something like Consul for months, and they didn't even realize this new thing was in there, and it could be helpful. So I'm going to go through each, highlight a major feature that we've done in each of those tools, and then just bullet point the other big improvements we made. So to start, we're going to start with Consul, and these are in no particular order. So Consul is stable and used at thousands, tens of thousands of companies on millions of servers now across the world. It has been very widely deployed, very successfully deployed, and so the theme that we've been focusing on with Consul this year, what we've been pushing with Consul is easing the management of Consul at scale, easing the operator burden of Consul at scale. And we've been working with some of our largest users to do that. And the feature that I want to talk about with Consul is something that we call Autopilot, and something we like to describe as self-driving Consul clusters with operator supervision. Autopilot is something that we've been working on for a while. We've shipped in Consul, and we're going to continue to improve in Consul. It'll just get better. But the idea behind behind Autopilot is it's split into two categories. We have safety features, which I'll talk about here, and then we have convenience features, which come in our enterprise version. And the goal of the safety features are to actively protect users and operators from putting Consul into an unavailable state by misconfiguration or misuse. And we do a bunch of things to do that. To get started, we shipped 3 safety features with the last version of Consul, last major version of Consul. The first one is dead server cleanup. So what dead server cleanup does is it replaces a dead Consul server when a new healthy server comes online. So previously, if you had a dead server, you would have to wait some configurable number of time, usually more than a day, for that server to disappear. And if you didn't orchestrate that correctly, then you could come in a state where there couldn't be a quorum in the leader election and causes a little bit of pain. And so what dead server cleanup does now is when you have an unhealthy server, as soon as it sees another healthy one, it immediately removes the dead server out. And that makes it very, very easy to upgrade and maintain Consul. The next thing we did is server health checking. So this is available via the API, but all the servers have a rich set of internal checks that Consul's doing. You could use this for your own monitoring. We expose it to you, but we actually use server health checking as a primary mechanism of driving Autopilot. So we just expose it to you, but it's used internally for a lot of things, including the next thing, which is stable server introduction. So what stable server introduction is when you introduce a new server, it doesn't actually see that server, it doesn't recognize that server as a voting member until all the server health checks pass. And so you could bring up a bunch of servers, and originally, or prior to Autopilot, as soon as the server came online and had network connectivity to the rest of the cluster, Consul would immediately make it part of the voting cluster. And now all the server health checks have to pass first before it becomes part of the voting group. And so these 3 things make up our initial set of Autopilot safety features. And then there's the convenience features of Autopilot. These live in Consul Enterprise only. The goal of convenience features are to just automate tedious tasks and improve sort of the enjoyability of operating Consul for things that don't necessarily risk putting Consul into an unhealthy or unavailable state. And so the features of convenience features are non-voting servers. So what non-voting servers allow you to do is they let you bring up servers and mark them as non-voting members. And the benefit of that is that you can improve read scalability of Consul without introducing load on the leader election process. You could add more servers than would have been advisable before because you can mark them as non-voting. In addition, or building on top of non-voting servers, there's redundancy zones. Redundancy zones solve this problem where people wanted to take advantage of the failure isolation domains of infrastructure providers in a way that worked well with the voting structure of Consul. So a great example for this is AWS availability zones. If you had 3 availability zones, you ideally wanted to run at least 2 Consul servers per availability zone so that within each failure isolation domain, if you had a failure, you would have 2 in there. The problem is 6 isn't really an ideal number for a quorum, but now that issue is gone. You could actually run 6 because you could teach Consul about how to recognize a redundancy zone, and then within each redundancy zone, Consul will manage who's a voting member and who's not. And by doing so, you always maintain a healthy quorum size. It might only have 3 voting members. You might be able to configure it 5, but that way you could run 6 or 8 or as many as you want now with the non-voting servers and keep your failure isolation healthy. And then the last thing is automatic upgrades. So with Autopilot, to upgrade Consul, you just bring up a new cluster with the new version, new server cluster with the new version, start it up, and only when there is a healthy amount of servers with the new version, it sort of atomically switches from the old to the new server cluster and makes all the old versions non-voting members. So that lets you really easily, it works really well with autoscale groups, Terraform, things like that, where when you upgrade Consul, you just spin up the new cluster and just wait, and it'll eventually switch over all in one. And so that's Autopilot. Autopilot's going to continue to improve. That's just the initial set of features that we're shipping with it. We're continuing to identify more ways that we could automate and make your lives easier as operators, but that's the initial feature set. We also introduced the concept of network areas, which enable non-fully connected distributed Consul servers to connect into the WAN pool. So in many higher scale environments, you don't have fully connected distributed data centers. So you have a hub and spoke model, or you have something a little more complex. Consul can now network through all of that. And then we also have auto join for AWS and Google Cloud based on instance tags. So if you're spinning up a Consul cluster in AWS or Google, there's no real bootstrapping issue anymore. You could use tags on the instance in order to find the servers. Consul will find these on its own using IAM roles or et cetera on the server and automatically join and connect. So it makes installing and operating Consul on these cloud platforms very easy, and we're extending that support to more cloud platforms currently. And so that's Consul. Moving on to Vault. Vault is very similar to Consul in that it is being used at a very large scale for very secure things, very security sensitive things. And so the theme that we've been focusing on with Vault this year has been similarly scalability related, operator related, but also just continuing the feature spread of Vault, because one of the goals of Vault is to try to centralize all your secret management into a single location. And so it is important that we support various features in order to not split your secret storage solutions. The highlight feature that I want to talk about with Vault is replication. So replication enables horizontal read scalability of Vault across geographically distributed data centers, so across WAN, across the WAN. Replication is really simple in its architectural, high-level architectural design. Within each data center, the primary and secondary here would be different data centers. You have a Vault cluster, so you run multiple primaries, actives and standbys, and one is the primary and one is the secondary, or one's the primary and or the secondary, and we do log shipping between the data centers. And so you have one primary cluster that has all the ACL, all the policies, all the roles, all the back-end configuration, and then it ships all that configuration out to all the secondaries which mirror it. Configuring this is super easy. These are the 2 or 3 commands, 2 commands on the primary, 1 on the secondary, that you need to run, and this will just turn on replication for those pairs. And there's some pretty neat things. So we sync all the mounts, the secrets, the policies, et cetera, but all the tokens and leases are cluster local. So that helps improve scalability quite a bit. It makes using it require a little bit more discipline, but not much, because the rule is basically just talk to one Vault cluster when you're using it. But since they should be data center local, you should just talk to the local Vault cluster. But what this does is lets you authenticate, and your token is specific to that cluster. When you request a secret and get a lease, all the lease management, revocation, that sort of enforcement is local to the Vault cluster. It minimizes the amount of traffic that has to go back up to the primary. And we do request forwarding for you. So as a client, you don't need to even know that there's primary, secondary set up. You just talk to it as if it were a primary, and anything that secondary cannot handle, it'll forward onto the primary and request forward back to you. So from a consumer client standpoint, zero difference. And from an operator standpoint, you get globally distributed replication of your secrets. In addition to replication, we introduced a number of really cool features. We have the TOTP backend. So one of the great benefits of Vault that I love touting is that it just gives developers an API for security. Whether you're encrypting things or storing secret things or needing a certificate, developers or users of Vault in general don't need to understand or become sort of topic experts of that thing, and don't need to deeply understand what sort of algorithms use or what key sizes or things like that. You hit an API, somebody's configured all those defaults for you, and you get your value back. TOTP extends that to TOTP. So I'm sure for all the developers in the room, at some point you've implemented two-factor authentication, and in doing so, you have to learn what this is and learn how to store sort of all the codes and everything associated with enabling two-factor. And what the TOTP backend allows you to do is it gives you a JSON API to do all of that. Centralized on Vault, audited by Vault, configured by Vault, and so on. So now to register a new user, you just send one request. To verify a code that a user gave you, you send a request, and it does that all for you, and that's not a concern anymore. The next thing we did is combine all the database backends into one, and you could use plugins to extend them now, third-party plugins. You could write your own plugin. And so Vault, since 0.1 actually, has supported various database backends to create database credentials. We shipped with Postgres support, MySQL support. We've extended it since then to many, many more databases. But now you could add just arbitrary database support. Or if you're not quite happy with how one of ours works, you could just add it. This one bullet point doesn't give justice to sort of more of the machinery underneath that we've done to extend the plugin system that has been battle hardened through Terraform and Packer and those sorts of things. The same plugin system, bringing it into Vault, but doing so in a way that we could enable secure plugins. And so that's all in Vault to do that. And then the last thing I just want to talk about is the CA certificate backend for SSH. And the SSH CA certificate backend lets you use Vault SSH, which lets you SSH into machines using your Vault identity, and use CA certificates instead, which solves sort of the same problem that the server fingerprints were solving. And so one of the difficulties in setting this up, this has been around as a concept for a number of years now, but one of the difficulties in setting it up has been running a CA. Vault turns out to be a quite decent CA, and so by building on top of that, you can now use Vault CA capabilities to enable SSH with certificates. And so then there's Nomad, and Nomad has actually had a really, really good year. And so I'm actually going to highlight two things that Nomad's been up to this year. Nomad is an interesting tool for us because unlike all the other open source projects that HashiCorp has, Nomad is being adopted by the largest companies first. And for us, it's generally gone the other way, which all our tools get adopted by sort of small hobbyists and go from there, and years later are being used at quite large companies. Nomad, from sort of the get-go to today, is still doing the opposite approach. The benefit is that we get to work on really interesting problems, and we know the stability of Nomad quite well. The downside is that you don't get to hear about it a lot sort of in the community and in Twitter and things like that because the companies using it are quite large. But we've been working on some interesting things in Nomad to help address some of these use cases, again, focused on our users and what they're seeing, but it enables some really interesting things that are unique to Nomad. The first one is something that we call dispatch, Nomad dispatch. And dispatch is parameterized jobs that can be invoked dynamically. Another way to put it is functions as a service in a way. They let you register a template for a job and then invoke it with parameters. So they're parameterized jobs, they're batch jobs, they're expected to complete at some point. Like I said, they're a function as a service, and in many cases they could actually replace your queues, in many cases. And so let me show you an example of what this looks like. Here's a video encoding job that we're creating. The parameterized block makes it a dispatch job, a dispatchable job. And in the parameterized block, you could put required parameters, optional parameters, and some other things. And then to dispatch to it, you use the dispatch subcommand. You give it the parameters that are expected and the name of the job that you registered, and then it queues it up and then dispatches it to available space in your cluster. So one of the big benefits of this sort of thing is it's great for longer running batch jobs like video encoding. Currently, it's not really recommended for really fast things you'd put in a queue that execute really, really quickly because there's overhead in building the isolated environment, launching the new process, things like that in order to get it going. We're working on improving all of that. But for large jobs, for longer running jobs, and especially for lower, even if they're fast and they're just lower quantity, dispatch is a great way to lower operational complexity by just having one system this is all flowing through. Because Nomad naturally has to do this sort of thing anyway for even its other jobs. It has to queue things up, it has to wait for available space, schedule when it's there, and so on. The benefit of dispatch sort of going forward is that you get much higher cluster utilization. You could have much higher priority services and things that are on your servers long running, but the available compute, memory, disk, and so on available on each server, you can now utilize all of that distributed across your whole cluster to handle your dispatch jobs, whereas in a traditional queue-based environment, you probably have workers on various specific machines that are just using some fixed set of resources. But now you could really take advantage of the sum total of what's available on your cluster in order to process these jobs. So dispatch is available already. It's really exciting and it's fun to use. The next thing I want to highlight, so there's two, is actually the Spark integration with Nomad. And this is a very new thing for Nomad, and it allows you to run your Spark jobs unmodified, scheduled by Nomad instead of Yarn or Mesos. And so I said on the subtext in the previous thing, it's a no compromised sort of big data with Nomad. And what I mean by no compromise is that it's just Spark. There's nothing weird about it. If you're using Spark, then it's the same workflow. It's everything you're used to with Spark. Nomad's capable of running. The only difference is currently you have to run a fork of Spark that we're maintaining and we're committed to maintaining in order to get it because it's not merged, but the PR is open. Yes, so it lets you run Spark jobs. You just use the same Spark submit workflow. And the big benefit is there's no separate data cluster and service cluster. So if you're running Spark today and you're using a scheduler, you have to run Spark and then you have to run something else on the side to handle your services and batch jobs and other things. And this unifies it. And actually in the Google Borg research paper, Google researched this and researched the overhead of splitting your clusters. And what Google found for their infrastructure was that if they had to split their scheduler between data and service, they anticipated that their infrastructure needs would rise 20 to 30%. And for something like Google, that's massively significant, but it's not ideal for anybody. And so by making one cluster that can handle all your types of workloads, you lower the costs, lower the demands of the infrastructure that you need, and you increase utilization across that cluster regardless. And so same thing when a service is running on a machine, but you have extra IOPS and you have extra memory and so on. Nomad may use that to run a Spark job. If the machine's particularly loaded, it will not. And so in addition to this, you get all the benefits of Nomad if you use this. So you actually can access Vault security secrets from your Spark jobs using the very sort of secure mechanisms we've talked about in other talks about how Nomad injects secrets into your jobs without Nomad being able to look at them or anything like that. You get multi-data center support. So you could schedule jobs across multiple data centers, Spark jobs across multiple data centers onto a single cluster. You get elasticity, which is a really big benefit for Spark users. The current world of Spark makes it very difficult to spin up 2,500 servers really quick to crunch a lot of data and then scale that back down to something like 200. The current operation of Spark makes that very difficult. With Nomad, Nomad sort of behaves natively in that kind of environment. It expects servers, clients to come and go, you to scale up and scale down, and it handles all that complexity for you. And like I said, it just looks normal. So you Spark submit like normal, and you specify a couple Nomad options, but otherwise you're just running normal Spark jobs. In this case, we're just running a Spark example. So very, very familiar, won't feel foreign to anybody using Spark. So the current status, like I said, is there is an open PR to the Spark project, but at the same time, we're actively maintaining and are committed to maintaining the fork of Spark, which is just rebased on Spark releases with the Nomad support in there. And so to highlight things, there was dispatch, there's Spark. We've also been working on rolling deploys, which allow you to use health checks as a mechanism to know when to gate sort of more deploys outwards. This is coming in the next version of Nomad, but like I said, lets you start a deploy and say, roll out by this step function based on these health checks over time. And so that lets you, canary things out there. And then there's the Vault integration, which came in a couple releases ago now, or maybe the last major release. But the Vault integration, like I said, lets you use Vault to get secrets into your jobs, but it does it in a way that actually the Nomad servers can never access your secrets. They can't. And if they tried to, it sort of shows up in the Vault audit log anyways. And so that's Nomad. And then I want to talk about Terraform. Terraform, I think the theme of Terraform in general has just been sort of explosive community growth and platform support and things like that. It just in the past sort of 6 months, the number of providers and resources has just skyrocketed in Terraform. So the theme of Terraform and what we've been trying to do with Terraform is actually improve the operability of Terraform in the sense of how do you handle the fast velocity of Terraform, getting the latest features you want with your cloud platform without sort of compromising your infrastructure and keeping yourself safe and things like that. We've done a lot to that. I actually spoke at the HashiCorp user group about the major changes we made to remote state and remote backends earlier this year. And what I want to talk about today is something coming in the next version of Terraform, and that is versions providers. So we are splitting Terraform core. We have split Terraform core out from the providers. If you've been around Terraform long enough, you know that when you used to download Terraform, you used to get like 30 binaries with Terraform, but those were still actually all the code lived in one place. We cut all the releases at the same time. They all shared the same version number. And then we shrunk that down into one binary. So if you've downloaded Terraform in the past, I'd say 18 months, you would just get one Terraform binary, which embedded, it had AWS and Google and all that knowledge in the one binary. And now we're sort of going a different direction, which is when you download Terraform, you're just going to have the one Terraform binary, but all the providers are going to be released separately with separate binaries, with separate version numbers, and Terraform will download them as it needs them on demand and as you configure it. So the Terraform CLI will no longer include any providers with it. For new users and existing, this will feel mostly invisible though, because the providers will be downloaded automatically by Terraform as they're needed. The providers are going to be released individually on releases.hashicorp.com, which is the release site we've used for years. It has all our tools are released there. But you'll find now, in addition to Terraform, there'll be Terraform provider, GCP version, 1.0 and things like that. And we'll release those separately. So we'll have probably multiple provider releases on a weekly basis for different providers. And those will just continually be released. One of the big benefits is you can now control the upgrade cycle between the various things. So for a lot of people, they want to take advantage of the bug fixes or feature improvements in Terraform core, but they didn't want to necessarily risk some of the stability risks of upgrading the AWS provider or one of your other providers, which may be working great for you. And so now you can control those separately. You could upgrade AWS without upgrading the core. You could do vice versa. You could do it all at once. In addition to this, you get the ability to constrain the versions of your providers directly in your configuration. So this is the configuration that we're adding to providers, which lets you use arbitrary version constraints to tell Terraform what to use. Modules could define their own versions too. So you're able to, if you share a module with people, you could say this works great with these versions of this provider. And if someone tries to consume that module with their own set of constraints that don't work, then Terraform will give you a nice error message up front telling you that there's incompatibilities and why. Terraform init is the command that we introduced in the last major version of Terraform. It's the one command that we recommend to set up Terraform. It's the one command where we do things sort of across the internet that aren't necessarily the providers that you have configured. It's the side effect command of Terraform. It's the only thing that'll do this. So you don't need to be afraid that any Terraform command may be downloading arbitrary binaries from the internet at any point. Only Terraform init will do that. And with the next version, we're only going to be downloading them from the HashiCorp releases website. We'll allow more sort of provider repositories in the future. But initially, it's just going to be over our releases with TLS and things like that. We verify checksums automatically. And then I don't think we're getting into this release, but in future releases, we'll also do the signature verification automatically with PGP. So when you run Terraform init, it inspects your configuration for the providers that you use. Just like prior versions of Terraform, you don't need to actively declare you're using a provider. If you had a resource that uses AWS and you never configure AWS, it'll just download the latest version of the AWS provider still. And just like this, you can't see multiple, but it'll download all of them in parallel, show you the progress, and when it's done, validates that they all appear to work on your system, and then you're off and running. For environments where you can't do this, for air-gapped environments, for custom providers, for things like that, there's a folder structure you could use that we'll look at first. So if we needed AWS 1.0, we look at a certain folder structure, and if we found the binary there, we do not reach across the internet sort of for any reason for that binary. So you could package up your Terraform configurations and share them. You could also have that directory shared among multiple configurations on non-internet connected machines or something like that, build machines, in order to make sure you're using the provider that you want. Another benefit of this is we get an improved community process. So an issue right now with providers is that to give you commit access, we have a lot of committers on Terraform working on providers, but an issue, especially with our larger customers for risk reasons, is that to give someone commit access to work on the DigitalOcean provider, for example, they also inherently become a core committer on Terraform, possibly, right? Like they could technically. Now we have these split out into separate repositories. They're all in the Terraform provider's GitHub organization. We could add individual committers to each individual project. The website, the issues, the PRs, they all live with each individual repository. And that is version providers. Like I said earlier this year at the HashiCorp user group, I talked about remote backends. Remote backends are our replacement for remote state. They're a superset. They enable remote state, but they enable a lot more too. Those have been quite stable over the last few releases of Terraform, although they were a really major brand new concept in the last major version. We introduced basic conditionals in the last version of Terraform, and we're expanding on that in the future. In the two versions prior, we have a Vault and Nomad provider that lets you do things like get your AWS access credentials from Vault instead of hard coding them or putting them into your environment some other way. Terraform could read those. The Nomad provider lets you initialize Nomad by setting up system jobs and configurations and things like that. And like I said, the growth in providers and resources has been really crazy this year. We're at almost 75 providers. We might be there now. With over 500 total supported resources. Terraform is definitely in a scenario where it's more likely to support what you need than not. And if it's not supported, it's very quick. So last week, I think it was last week, for example, DigitalOcean came out with their firewall feature. And we didn't know about this in advance. We do know about a lot of things coming in advance, but we didn't know about the DigitalOcean firewall feature. It came out, and then sort of within 6 hours that night, that evening, we had a pull request fully implementing all firewalls. And we were able to cut the release the next day. With the new split providers, we're able to do that really fast. So right now, it's hard because maybe we get the new feature emerge right away, but that forces us to release all of Terraform, all providers, in order to support that one feature, and we may not feel comfortable doing that. And now going forward, for that DigitalOcean example, for example, we could have, as long as it passed all the acceptance tests, we could have merged it and cut a new release that night just for DigitalOcean, just to give you the access immediately. So this is going to be great. And then the last one I want to talk about is Packer. We don't talk about Packer too much sort of on stage anymore. It's been around a really long time. It's really stable. And so it's sort of fitting that the major thing we've done with Packer this year is make it a 1.0. So Packer's finally a 1.0. It's a commitment from us to long-term stability, as well as sort of a representation of success. And the definition of this is on our website, and we explain why it's a 1.0. But Packer's, I think, 5 years old now or so, and so it's very, very fitting. To get to Packer 1.0 is a pretty monumental effort by the Packer team. There was over 1,000 issues closed. A lot of them were already fixed or invalid. A lot of them were actually had to be resolved, like things were shipped to fix the issue. And the PRs, sort of, we got down to less than 100 at one point from I think it was like 500 or so. In addition to that, as part of the road to 1.0, as part of the 0.9 releases, we introduced dozens of new builders, provisioners, post-processors, a ton of new stuff that we incubated in a 0.9 release for bugs and so on for a number of months, I think over 6 months before we marked it as a 1.0, and just lots of bug fixes. And so Packer's been used, or is being used, in production sort of pipelines for many, many, many years. And Packer 1.0 is just a representation of that. And so those are the updates, the major updates for all our tools. We have the team leads for a couple of our tools here today. I know we have Consul, Vault, Nomad. I think those are the 3 that we have present here. We have engineers that work on pretty much everything here. So you could ask any HashiCorp person about any of these tools, and if they don't know the answer, they will forward you to someone who does here at the venue today. And we have a bunch of talks coming up on, to go in more detail on some of these, so thank you very much.